Hello everyone. During this lesson we will discuss depressurization using Aspen HYSYS. My name is Wilson. I am a senior process design consultant. First, we will discuss some basics like what is depressurization? Why we depressurize? What is the 50% and 15 minutes API criteria? Then, we will see the practical application in Aspen HYSYS software. Depressurization is a very important topic with respect to oil and gas industry. So, the question is, what is depressurization? Let's assume there is a two-phase vessel, which we want to depressurize. The inlet line to the vessel is with a shutdown valve. Vapor outlet and liquid outlet line also have the shutdown valves. If I want to depressurize this system, I have to close all the shutdown valves. Now, I will use this depressurization line, which is going towards the flare. I will depressurize the system by operating the BDV. This BDV is followed by a restriction orifice. During depressurization study, we ultimately try to find what will be the size of the restriction orifice and the size of a tailpipe. Now, the second thing, why we depressurize. There are three main reasons to do depressurization. First, to reduce the risk of vessel rupture or line rupture because of thermal stresses during a fire scenario. Now, second reason, to minimize the fuel inventory, which could supply a fire. Third one, to minimize the release of flammable or toxic product in case if it is not ignited. Now, the other question. What is API 50% and 15 minutes rule? As per API 521, if there is a pool fire, then you have to reduce the initial pressure to 50% of the vessel design pressure within 15 minutes time. This criteria is based on vessel wall temperature versus stress to rupture the vessel. It is applicable, generally, for a carbon steel vessel with a wall thickness of 1 inch. Let's move to the software to see a fire case scenario example. So, starting with a new case, first we will add our components. The components are methane, propane, and butane. Then, choose the fluid package. All are hydrocarbons, so we select Ping Robinson. Now, move to the simulation environment. Place the material stream. Double-click the stream and input. Temperature 15 degrees Celsius. Pressure is 50 bar gauge. Then, mass flow rate is 100 kilogram per hour. You can take any mass flow. It will not affect your study. Now, go to composition option and input methane is 0.6. Then, propane is 0.2, and next is also 0.2. Now click OK. The stream is solved. Now, add a two-phase separator on a flow sheet. OK. Connect the inlet stream to the separator and draw the outlet streams by holding a control button. You can see that separator is also solved. If we look at our case, according to API standard, we have to reduce the pressure to 50% of the PSV set pressure, which is basically our vessel design pressure within 15 minutes or less. So it's mean we have to reduce the pressure from 50 bar gauge to 25 bar gauge. If we see vessel dimensions in this case, the diameter is 2 meters and the height is 6 meters. MDMT is equal to inner wall temperature minus 3 degrees Celsius. The constraint in the case is our flare header is unable to handle any flow greater than 5,000 kilogram per hour. Now from home, go to Blowdown and Depressurization, then select Blowdown. If you see template option, multiple templates available, for our case, single vessel blowdown is a better choice. So we select a single vessel blowdown template. Then click Start Analysis button. Now, in Design option, we define number of segments and lines. You can define maximum 5 segments for each line. If you set all the lines to 0 segment, means blowdown model a single vessel without pipe. We actually provide these values to get volume, surface area, and hold up in the equipment upstream of the orifice. If there is significant change in pipe diameters or metallurgy along the line, you will take more than 1 segment in a line. Generally, 1 segment per line is fine. We are just considering a tailpipe to make this case simple. So we keep the tailpipe value 1 and make the other 0. Now, move to the other options. We keep inlet line without pocket. Then, blow down line attached to the vessel. Also, vapor outlet line leave the vessel vertically for our case. You can select the options according to your case need. Now, move to the system option. If you see, most of the things are in red color. In the input menu, first, we provide the template parameters. Put ambient temperature, 25 degrees Celsius, and the airspeed 1 meter per second. Then put equipment condition upstream of the orifice. The initial temperature is 15 degrees Celsius and pressure is 50 bar gauge. It is a fire case, so fire zone option should be checked. Now, select main vessel from initial inventory option. Then, choose link to stream. Click the Find Stream button. Select main case. Stream 1, which is your vessel inlet stream. Now, move to Fire Zone Vessels option and select the main vessel. Keep vessel orientation vertical. Put length 6 meters and diameter is 2 meters. Wall material is carbon steel. Cylinder wall thickness is 30 millimeters and head wall thickness is also 30 millimeters. Now, move to initial condition and provide liquid volume percent, 20%. After initial condition input, move to simple fire option. Set environment factor 0.3. Because our vessel is insulated, we can use this environment factor table for a reference value. Now, move to pipes option and select the tailpipe. Put the values for the case. Schedule is 40. Pipe diameter is 100 millimeters and the length is 10 meters. It is a horizontal pipe, so the elevation change is 0 meter. Go to initial condition. Put temperature 25 degrees Celsius. Because when this BDV is not open, the tailpipe is in contact, or you can say in equilibrium with the ambient conditions. Let's assume 1.5 bar gauge is the superimposed back pressure. It's mean it is the maximum pressure that exists in the flare header. Now move to orifice option. Assume orifice diameter is 25 millimeters and discharge coefficient is 0.6 in this case. Now go to run control option. Put the time 15 minutes in the halt condition and pressure 50%. So in our case, it will be 25 bar gauge. If any of these criteria met, the simulation switch to hold. Click the Run Blow Down button. After some time, blow down run will complete. If you move to Result Summary option, you can see different plots. Now, select Major Findings to see the status. You can see that run ending time, final pressure, and some other useful details are available here, like minimum wall temperature. So for our case, the MDMT. MDMT stands minimum design metal temperature is equal to minimum wall temperature minus 3 degrees Celsius. You have to report this value to piping engineers. Then, they can select right pipe material. In our case, carbon steel pipe will be good. You can notice that the flow is above our case limit, so we can reduce the orifice size further to manage it. Currently, we have some margin in the time. Go back to System menu and select Orifice. This time, input the size 15 millimeters. Now, run blow down again. Now, move to Result Summary, then see the major findings. You can see that flow is well below 5,000 kg per hour. So, this is good now. Thank you. If you want to learn new skills online, join our expert lead training courses. Visit our website, www.omesolglobal.com, or send your queries at admin@omesolglobal.com. For more videos, you can follow our YouTube channel.